Hello everyone, I'm Sebastian Y and this is Managerial Economics. Over the next few videos, I'm going to do a review of the mathematical techniques that we're going to need for this course. In this first video, I'm going to go through the basic rules for derivatives. First of all, a little bit of notation. For this video, x is going to be our choice variable. For a generic function f of x, there are two ways to denote the derivative. The first one is df dx. Although this looks like a fraction, you don't treat it as one. This means the derivative of the function f with respect to x. This is what we call Leibniz notation. The other way to denote derivatives that you may have seen is called Lagrange notation, and that's f prime of x. These two things mean the exact same thing. I generally tend to use Leibniz notation, but will occasionally use Lagrange notation if it's convenient. Let's talk about the basic rules of derivatives. Number one, the derivative of a constant is 0. We write this as dA dx equals 0, where a is just a constant. It's just a number. Derivatives tell us the rate of change of a function as x changes. Since a number is always just that number, it can't change, so the derivative is going to be 0. For example, the derivative of 10 is 0. Rule number 2. Constants can be factored out of derivatives. So if we take the derivative of a times f of x, we can rewrite this as a times the derivative of f of x, a times df dx. For example, we want to take the derivative of 3x squared, that is equal to 3 times the derivative of x squared. You can always factor that out. Rule number 3. This is sometimes called the power rule. It states, to take the derivative of x to a power, multiply by the exponent and then subtract 1 from the exponent. I also want to point out that this rule always applies no matter what the exponent is. It can be a negative exponent, it can be a fractional exponent, does not matter. You multiply by the exponent and subtract 1. We write this as dx to the a dx equals ax to the a minus 1. The a exponent comes down to the front, multiply by that, and then we subtract 1 from the exponent. For example, the derivative of x to the fourth is 4x to the third. Rule number 4. The derivative of two functions is the sum of the derivatives of the individual functions. So if we want to take the derivative of f of x plus g of x, f of x and g of x are just generic functions, that's going to be equal to df dx plus dg dx. We can just split these apart and take the derivative separately. For example, let's suppose we wanted to take the derivative of 3x to the third plus 4x squared. This is equivalent to taking the derivative of 3x to the third plus the derivative of 4x squared. We can then apply the power rule and get 9x squared plus 8x. Note here that when we have a power of 2, 2 minus 1 is 1, and so we can just leave that off. The fifth and final rule is called the product rule. And this gives us a rule for taking the derivative of the product of two functions, f of x and g of x. We take f of x times the derivative of g of x plus g of x times the derivative of f of x, df dx. For example, if we want to take the derivative of 2x times 3x squared, 2x is f of x, and 3x squared is g of x. So we take f of x, 2x, times the derivative of g of x, which is 6x. Again, we're going to use the power rule there to bring the 2 down, multiply by the 3 to get 6, plus g of x, which is 3x squared, times the derivative of f of x, which is just 2. What we end up with is 12x squared plus 6x squared, which is going to be 18x squared. Before moving on, I want you to make sure that you're feeling comfortable with using each of these rules. Of all of these things, we're going to be using rules 3 and 4 the most. Between the two of these, you have pretty much everything you need to calculate the derivative of a polynomial function, which is going to be the most common thing we will do. Take that polynomial, separate it out into parts, and then take the derivative of each one of those parts using the power rule. If you're not feeling comfortable with any of these rules, feel free to ask. In the next video, we will apply our knowledge of derivatives to do some optimization.